Hey, hello, everybody. Welcome to the webinar. Let us get started. I think we have a few people joining late, but this session should be recorded. So anyone that is unfortunate enough to have other things to do on a Tuesday morning, afternoon can catch this on the replay. Let's get going. Okay. So hello, everybody. Thank you for joining this webinar. I'm David Severski. I am a senior data scientist and a partner here at the Cyentia Institute. I am thrilled to be joined today by Olga Livingston from DHS CISA. Olga, would you care to say hello yourself?
Thank you for the intros. Yes, I'm Olga Livingston. I'm leading cyber economics portfolio for CISA and done quite a bit of research on cost of cyber incidents in the past. So very happy to partner with Cyentia on delivering knowledge to the people.
Knowledge to people. I love it. Really thrilled to be back here again. I think it was a fall day way back in the before times, 2020, when we were talking about IRIS 2020 as well. In fact, I think I may have been wearing this exact same overshirt. So it feels like back in the past, but still doing awesome stuff. So really thrilled to be here and to share all this with you there. We do have a link down in the bottom left-hand corner there with a fancy QR code. If you care to link to cyentia.com/iris, you can find all the reports we're going to be talking about here today there. They're free for download, no registration required. So without further ado, let's get started. Just in terms of general housekeeping, this is a standard Zoom webinar there. You can use the Q&A panel to ask any questions. We should have plenty of time at the end for any questions there. I will try to keep an eye on the Q&A panel during the presentation there, but I don't multitask all that well. So definitely we'll try to get them to at the very end, if not during the conversation. So with that, let's get started. Cyentia and the IRIS. Hopefully many of you have been familiar with IRIS, the Information Risk Insight Study. We started this way back in 2020. Cyentia Institute, we do a lot of research working with partners such as Kenna and Cisco, Veracode, et cetera, there on the control side of the equation. IRIS is really where we're looking at what happens when all of these controls, such as vulnerability management, patch management, security software scanning, et cetera, what happens when they fail? There's been a dearth of knowledge about what are the real losses in terms of verifiable information and the actual frequency of these events that has been happening. So in 2020, we came out with the groundbreaking, if I may say so, the IRIS 2020 report, which took a look at hundreds of thousands of these events there and seeing what can we actually learn from this. We followed that up with at least 2 reports since then, one of them being the IRIS 2020 Extreme, where we looked at 100 of the largest events over time and see what was different about these large mega events. And we also looked at IRIS Tsunami, which is looking at multi-party events, whereas the Extreme looked at single-party events that were very large. Tsunami was much larger, looked at those events that span multiple organizations. For both Extreme and Tsunami, we were delighted to be partnered with several sponsors such as Visible Risk, Interos, Risk Recon, CyberGRX, et cetera there. And now we have the wonderful sponsorship from DHS CISA.
And we're happy to be partnering for multiple reasons. I guess I mentioned first how I came across the analysis is when CISA did the systematic review and cross-validation of all the studies that touch on the cost of cyber incidents, that's where I came across the 2020 study and reached out, and a beautiful relationship started. So the emphasis here is that there are multiple studies out there that provide you the estimates. What we've done is in-depth review of assumptions, limitations, methods, disclosure. And this is one of the few studies, and we're partnering with a couple of organizations, but this is one of the few studies that came very close to the golden standard of analytics, which is reproducibility without recourse to the author. All assumptions and limitations are clearly stated, data collection and sources are well-defined, and what's more important, there is none of that black box fairy magic dust. Math hasn't changed in the last 100 years. Those of you that know how to reproduce an analysis would be able to, but you're probably in the 1 to 5%. Everybody else needs a digestible summary of the summary to inform their risk analysis and prioritization. And we were very happy to have that credible resource going out on the street. Thank you.
That's fantastic. Thank you, Olga. We're super excited to have your sponsorship and your support on this endeavor there, because we think it's really valuable, and it's great to hear that other other people find it valuable as well. I should mention, building upon Olga's comment there, that the data we're operating on here is primarily based upon the Advisen part of the Zywave family cyber loss fee data set. This is a commercial data feed that's available for subscription out there. We're not selling anything there, but just to let you know that information is available, and it is largely derived from publicly available information. So this is FOIA requests, breach notifications, news information, et cetera, as well. Does this represent every single event that's happened from information security over the past 10 years that we're doing in our study? Absolutely not. Is it, however, a representative sample of the events that make the news, that are newsworthy? Absolutely, we believe it is so there. And so we believe that this information is representative, even if it's not comprehensive. But then we really haven't found a comprehensive data source. So who is the IRIS for? There are so many use cases for IRIS there. These range from people that are doing cyber risk quantification, whether that's FAIR or bow tie analysis or some other kind of mathy type of analysis there. We certainly have that use case covered. It's one that's near and dear to our hearts, as many of us here at Cyentia are former FAIR practitioners ourselves when we were back in the practitioner space. But there's much more than just cyber risk quantification that could be applied here. There's insurance buyers. If you are in the market or maybe in the market for buying cyber risk liability insurance out there, you may need to know how big are these events, so that when you're trying to size policies, how do you size them based upon what you're concerned about in your organization? Well, the IRIS can help you with that. Information security strategists, when you're trying to decide what controls to deploy out there, or what are the things you need to be most worried about, how do you prioritize your efforts? That can also help you as well. SOC analysts, again, a very close parallel to security strategists, but on a more tactical level, what types of malware, et cetera, and campaigns you need to be worried about. IRIS has your back on that as well. Vulnerability managers, of course, saying which vulnerabilities have been most common in these data sets, GRC professionals out there, and so many more.
Well, and if I may add, if you're dealing with risk prioritization, where you want to prioritize scenarios, do you really need precision and accuracy to each event, or do you need a rough order of magnitude that allows you to do relative comparison, relative ranking to say, here are the 5 or 7 things that I really need to worry about, and then you would pursue risk quantification. You're not going to do it for everything. So either way, this is sufficient information to start down the path of risk prioritization or scenario prioritization for your planning.
Absolutely. Thank you for that, Olga. You know, something that I always was asked when I was on the practitioner side of the table was, how do we compare to others in our peer group? Well, IRIS is a way to ground that, what is your peer group and what is happening there quickly, so you can focus upon what most risk practitioners, in my opinion, are best at, which is saying, how does my firm differ? If I'm a financial banking institution, if I'm an information services technology firm there, you may not have in-depth knowledge of what's happening in every other single organization in your industry sector, but you know, hopefully, what's going on within your particular firm, and how does that better or worse than your peers? Where are you stronger? Where are you more challenged? And IRIS is meant to help you get to the area where you can focus on quicker and get to that sense of what is happening in my peer group and get on with the business of managing risk. So with that, let's talk about loss event frequency. We use terminology there that is largely based upon the FAIR taxonomy there. We have loss event frequency, how often does a bad thing occur, and loss magnitude, how bad does it hurt once it occurs there. This is not wedded to the FAIR taxonomy, but it's a good way of thinking about problems in my experience. So if we do a flashback to what we did in the IRIS 2020, you may remember this chart if you've read that report. If not, you can download that for free. It's still relevant out there on cyentia.com/IRIS about the annual breach likelihood among firms by sector. And you see here, we've got a number of sectors listed from administrative way up at the top, having about 0.82% chance of any single firm having one of these events, all the way down to entertainment with less than 0.25% there. And while we believe those numbers are accurate based upon what we knew at that time, those are very small percentages. And we were trying to figure out what is that an accurate representation of what's happening based upon what we know and what we're seeing out there in the industry. We have a few insights that we had from that. First being that the loss event frequency based upon sector alone is going to be heavily skewed based upon those sectors that have smaller firms. It's very tough to get information about what's happening at the smallest of firms. Those are, under the 50 million or more based upon some definition of small and medium-sized businesses out there. There's so many of them out there. Many of them are not publicly underneath SEC trading regulations, so they don't have the same sort of breach disclosure laws as the larger organizations. And one of the things that we've seen is that organization size has a major effect in terms of orders of magnitude on loss event frequency. A Fortune 1000 financial firm has a much different loss expected frequency than a small firm, even within the same sector. And to calculate those percentages, you have to know what is the size of the population. So if you're trying to figure out how often do these events occur for the financial sector, you have to know how many of the financial sector firms are there that could potentially have one of these firms. And that's hard to count, but it has a huge effect on the loss of expected frequency. In IRIS 2020, we looked at the Fortune 1000, which was a very convenient grouping to look. Not only are they very large, but you know exactly how many of them there are. There's 1,000 of them, more or less. And we know exactly who those firms are. In IRIS 2020, we believe that our denominator last time, that population was probably too large, almost certainly too large. And so to solve that, we have upper and lower bounds for loss expected frequency now. We'll talk a little bit more about that right now. So how did we handle this population of, this question of the population size in IRIS 2022? Well, we have two approaches out there. Ultimately, our goal is not to give you a single number because we believe that single numbers are not a great fit and that trying to choose a range and to give you directional guidance is much more important than ultimate precision that is accurately wrong. So what we've done here is give a upper bound, which is a risk averse estimate. So this is kind of a worst case scenario of saying if you are really gun shy of taking on a risk there, we can calculate out what the upper number of organization is over the entire measurement period. And we're using a 10-year period here from 2011 to 2021 is our measurement period. Where we can look at the total number of organizations that we have observed as ever occurring over that entire measurement period. On the other side, we can take a lower bound, a risk tolerant approach there, where you are more willing to take on risk because you have more resilient controls and so forth out there. Maybe you're carrying more insurance, or maybe you just need to move faster in your particular organization. Where we're looking at the total number of firms suspected to be present in the population, where we're looking at information such as Dun & Bradstreet and other information to figure out what is the probable size of a given sector or given population. And between those two bounds, we get the upper bound and the lower bound. Olga, did you have something to add?
Oh, yeah, absolutely. We want to strongly encourage everyone to use those ranges because it is a way of capturing uncertainty in estimates. It's like, is it a Mickey Mouse way? Maybe, but with the sparse data that we have, and it's a recognized challenge in this industry, please preserve the ranges because point estimates, however easy and intuitive, are precisely wrong. So please, that information is there for you. Be cognizant of your upper lower bounds and then operate within these guardrails because your outcomes would be quite different along the range.
Fantastic. Thank you for that. So even though we have upper and lower bounds, we use those throughout the report there. In this presentation, we'll primarily talk about the upper bound just so we don't have to have double slides for everything in much of this discussion. So let's talk a little bit about how good is our fit here. So what we've done is we've taken a look at the loss expected frequency, how often of these are to occur there, and we fit this to a distribution. And we found that through looking at all kinds of different distributions, the Poisson log normal is the best one for this particular data set. Now, every time I mention Poisson log normal, one person gets really excited, and that may be Olga here because she's smiling there. And everybody else is just like, oh my gosh, this is like flashbacks to high school math and so forth.
Well, if I may, this is the beauty of bringing knowledge to the people is that we want to educate, not inundate. But however, those of you that know what you're doing can reproduce this. Those of you that look for a shortcut, here's a full parameterization of that data generating process. It's a distribution. You can simulate from there and have full equivalent behavior. So we're strongly encouraged to rely on that, but ranges and visual representation is included as well. So that's one of the standards of how we want to proceed, is anybody who wants to reproduce this behavior can, without dealing with the intricacies of an anonymized data set where you cannot necessarily work with the raw data itself. This gives you the information that you need. Therefore, the excitement.
Thank you, Olga. So what we're looking at here are these blue bars, which are our simulated, how good is our distribution fit? And these gray bars are what do we see in the actual data out there? And you can see that at least, when you're talking about 0 events all the way up to at least 4 events there's very little difference between what we saw in the data and our fitted distribution. There gets a little bit more room for potential error as you get into a very large number of events happening in any given 12-month period there. But in general, this distribution fits the data really well. So you can have high confidence that this is a true representation of what we're seeing. Now, as Olga said there, we're trying to short circuit analysis there. And if you're not using some sort of a Monte Carlo or math-based approach to doing risk analysis, that's totally okay there. You don't have to use that. We also have one of my favorite tables in the entire IRIS series, which is this probability of experiencing at least one event. And I sometimes call these clip and share. I think I always call them clip and share events, to be honest, because I say it every time. I really love, taking this, clipping it out from a printed copy of the report, laminating it and sticking it in your wallet. And so based upon the size of your organization as measured by revenue, you can say, what is the probability that my specific firm, based upon this particular data set, is going to have at least one, maybe more of these events in a given year? And we can see here that on the upper bound, these numbers are largely consistent with what you see for the largest firms, the lower bound. Upper bound, over 100 billion, 32% of having at least one event in a 12-month period, about 30% on the lower bound. So that doesn't differ much. Where you start to see much more effect on this is on the smaller side of the equation there. So the smallest other organizations there, from that 10 million to 100 million there, have about a 1 in 10, a little bit over 1 in 10 chance of having one of these events in a given 12-month period. Whereas in the lower bound there, it's still, just as we saw there with IRIS 2020, it's less than 0.5% in change there. So that gives you a good operating range of between 0.5% and 12%-ish of, what is the probability that a given small firm of this nature will experience one or more of these events in a given 12-month period. So love this very much there. I hope you find it as exciting as I do there. Not necessarily the flashiest visualization, but I think this is really great data to have for risk managers of all sorts. But we can still rank these based upon sectors. So much like we did in 2020 and 2022, we've said based upon the information that we have today, how do these sectors differ? And so right down the middle there, we've got relative to the public sector. So using the public sector as our bellwether there of middle of the pack, how does every other sector as measured by NAICS code, North American Industrial Classification System there are many other standards there. NAICS is what we've standardized upon there. How do these differ? So for hospitality, it is our highest propensity to have one of these events at 1.17 times the rate of the public sector. Construction is way down the list there. We think that is partly because we don't have a lot of information on the construction sector. We have great information upon hospitality, information, education, et cetera there. Construction is a little bit sparser in nature. Anything that jumped out at you from this particular chart in helping critical infrastructure out, Olga?
Well, we have our sectors of concern where we pay close attention, but this certainly also informs prioritization and planning, because depending on what sector you're in and depending on what size of business you're in, that's your intersection or that's your cross-section to inform your ROI analysis, break-even analysis. So even though a precise number is not to be had, you have ranges that help with that, A, raising risk awareness about cyber, but B, also do a meaningful calculation saying, yeah, I'm asking for $300,000 to do something. That's not the terms that those that a previous budget can relate to. However, saying that, well, it's 1 in 3 chances that this is going to happen, and for our sector and business size, here's the cost. That is a very powerful start of the conversation.
Fantastic. So that's loss event frequency in a nutshell, but let's talk a little bit more about loss magnitude. So this is a chart that's really important. So there's so many numbers that are put out there in the press and in boardrooms and in risk conversations out there about what is the average size of a loss. And average is a really dangerous term. We actually go into this in more depth in the report there, but you can see here, this is all the various losses we had on this. And this is roughly in a bell curve, but it is on a log scale. So you see we go from 100 million to 1 billion very quickly in this chart. And if you look at typical losses as measured by median, which is the middle of the pack, or a geometric mean, which is a more, it's a fancier type of average that actually accounts for having extreme values, they tend to agree. It's about $260,000 for a typical publicly discoverable breach or a publicly discoverable loss. However, there are many cases where it is much, much worse. These are kind of the, if you have a really bad day, it can be extremely bad. So what we have here is the 95th percentile, which is the loss of at least 52 million. So what we're saying is a typical loss, $260,000, but 5 times out of 100, you're gonna have a much greater loss of 52 million, all the way up even into the billions of dollars.
And this is where I'd like to chime in and emphasize the risk or danger of using point estimates, because, for example, in the previous edition, the average, for example, for public sector was exactly 95th percentile. So that just tells you how the point estimates, however intuitive, are very misleading. And if I may please address one of the comments in the chat, is when we say, I've tried to glean a correlation between the investment in cybersecurity and likelihood of something occurring, please keep in mind that threat and exposure is quite different for these organizations. So it's not just everything else held equal, it's not. But I appreciate the predicament, and when I emphasize that, that's exactly why I'm doing a range and more in-depth analysis and estimates, because using averages does get you that misleading picture. Thank you.
Thank you very much, Olga. So in addition to typical and extreme, we see this pattern across size of organizations. So we're looking here again at our largest firms, those of 100 billion, all the way down to firms very tiny of less than $100,000 in annual revenue there. And we see this typical pattern where there's a typical value where, for a firm that is 100 billion or more, $1 million loss is certainly not trivial, but is not threatening to the existence of the organization. But that extreme value is much, much higher. So for a small firm of the 1 to 10 million, sure, they may have a typical loss of 142,000, which is not good, but they may have, again, that 5% chance of having lost greater than 13 million. So that is a huge valuation change there. And so small firms need to take note. And just to beat on that drum a little bit more, we can look at this overall and say, look at all the losses as a percentage of revenue. The red dots on the top section there are representative of the losses experienced by firms that are $50 million or less in revenue. The blue dots are ones that are experienced by firms that are 50 million or more in revenue. And what the first thing you might see here on the left side is that almost 2/3 of the losses are less than 1% of annual revenue. And so your first takeaway may be, well, maybe this problem isn't so bad. But if you look at the distribution for those 50 million or less firms there, it goes way out to the right as a multiple of revenue. And it means that, of those losses that exceed 10% of annual revenues, nearly 9 out of 10 of them are happening to small, medium-sized business. So a shorter way of putting that is that small and medium-sized business is much more in jeopardy in terms of losses than the larger firms. And that can be for a variety of reasons. It may be, fines, it could be ability to tolerate loss, et cetera there. And it goes even a little bit further, is that you can barely see on that 1X on the blue dot there that all but one of the recorded losses that exceed 100% of a firm's annual revenue are entirely borne by small and medium-sized businesses. And that's really troubling if you're in that sector. We can also look at, what has the distribution of losses been over time? So this is where we take a little bit of a difference from our 10-year span that we typically illustrate here, and we're looking at the full 20-year range. I forgot to mention at the beginning that one of the things that we have done differently in this version of the IRS 2022 is we've taken inflation into account. It's a topic that's on many people's mind these days, and it's certainly on our mind from a risk analysis and risk management perspective as well. New in the IRS 2022, we are now accounting for the effects of inflation. So all the numbers that you see throughout this report and throughout this presentation are indeed adjusted by inflation out there. So we're comparing apples to apples, and certainly when you go back as far as 2000, 2001. So what we're looking at here is a scatter plot, and it's very busy, of course, there. Every blue dot on here represents a measured loss on a yearly period there. The box plots that you see here with that middle bar out there represent the median or typical losses for some variation there. And you can see it doesn't vary all that much. The takeaway here is that the typical size of losses hasn't changed very much over the past 2 decades. But what has changed, you may notice, is that there's many, many more blue dots as you get further on towards the right. In 2000, there's a few. If you look at something around 2010, 2011, it really picks up there, and there's many, many more of those events. And those are representative of much more of activity coming in place. It doesn't necessarily mean there's more activities happening, but it could also be because we have better reporting laws, et cetera, out there as well. But there's certainly a lot more of these going on out there. We also marked on here the 95th percentile with that red diamond, which is representing the 95% valuation that we've used in all the other previous slides there. And that is slowly showing an upward trend. We don't really see a significant trend of that right now, but it's something we're continuing to watch. Oh, did you have something to add?
Yeah, I wanted to address one of the questions in the chat, but also relate to that 95th percentile comment. Is those of you that are interested in the extreme events, as we mentioned, there is a separate study and also the extreme loss chapter section within this edition of the report. So please, that's there for your consumption.
Fantastic. Yes. And so this is looking at, this is another way of looking at our distribution of loss parameters. So just as we had the bar chart previously that showed how well is our fit for loss event frequency, now we're looking at parameters of loss. How much does this hurt? And how does loss magnitude differ from loss frequency? Well, loss magnitude, you can have fractions of dollars. You can have $100, you can have $101.25, whereas a loss frequency either happens or it doesn't. You can't have 1.5 events in a given period. You might have an average of 1.5 events, but you can only have 1 event or 2 events or 0 events. It's just a discrete distribution in statistical terms. So with the loss magnitude, we now have a continuous distribution where we have a log normal distribution. Again, you have a mean and a standard deviation, and you can see that our fit here, the line underneath represents our actual parameters that we used, and all the blue dots represent what do we actually see. And you see that this fit is fantastic. They're right on top of the line until you get out into the really extreme areas of 1 billion or more, where you get a little bit of noise, but it's still directionally adequate. And that's representing saying that for most events, we can well represent that data of observed events with these parameters, perhaps a little bit more on the very extreme events, but if you're out that far in the extreme, there's a lot of weird stuff that happens.
There is
those of you, okay,
yeah, there is a question whether this curve is representative for all organization sizes, and that's what we want to emphasize both on this slide and next slide is that no, this is a generic historical behavior for the entire sample.
yes.
If you want to do a subset analysis, that's certainly a possibility. So the distribution parameters presented here, they're for the entire sample, not for the subset of interest. And as Dave mentioned before, there is a variability of magnitudes by firm size and by sector. So that's a subset analysis that you need to pursue further to inform your specific question.
Absolutely. So the takeaway on that is that, yes, these LECs do differ. These LECs that we're just about to talk about do differ based upon organizational size. They can differ based upon industry, et cetera there. It's too much for us to include in one report there, but this is the type of analysis that is possible to do. Speaking of LEX, or loss exceedance curves, this is a figure chart that is very common from insurance. If you are familiar with the factor analysis for information risk, or FAIR, you may also see this quite a bit there. It's essentially combining the loss frequency that we saw with the loss magnitude, running a bunch of simulations, and then saying for any given, in this case, 12-month period there, what is the probability that you will have at least this much loss? So now we're kind of looking at the overall aggregate risk, if you will. We're saying that you have an 8.6 chance of having at least 100,000 or more loss in a given 12-month period. That goes down quite a bit. If you look at this 10 million mark, you can have a 1.8% chance of having at least this much loss, perhaps much, much more. But there's a chance of having at least this much should be expected based upon the overall population and their overall data that we have available.
And that's, again, the emphasis is a cumulative, complementary cumulative distribution curve for the entire sample. So for subset analysis, you need to drill into that. But that's the type of analytics that this data set and approach supports.
Absolutely right. So we've seen time and time again here that there's a lot of difference in the tail, those extreme valuations there. So we want to figure out how much should we be concerned about that, because there's the common course of operation risk, and then there's that extreme risk calculation. So just as the LEC, or loss exceedance curve, comes from the industry, comes from the insurance industry, we're also taking a page from them using another calculation called a tail value at risk, saying that once an event becomes really truly catastrophic, what is the typical expected valuation of that? And that is represented in this chart, in this table in the top right-hand corner, showing that based upon the revenue size, what is the total amount of risk a single firm has at the 90% level, at the 95% level, and at the extreme one time out of 100-year flood style event there. And you'll see that these numbers are much larger than things that we've seen previously. For the upper bound there, that can be 5 billion, all the way up to 46 billion, 46.5 billion almost, for that 1 in 100 style event.
And again, to emphasize this is all historical data. So there, if you want to take it further, you would need what-if analysis on things that have occurred, but what the losses would be had they unveiled differently, and also threat casting. What are the things that didn't happen but could have happened? So those are the two components that certainly part of risk analysis is not represented here. But if you're doing risk prioritization for planning, that's not necessarily the degree of a deeper dive that you need. Therefore, please be cognizant of what analytics you need for what level of decision making. This is a trap that we often fall into.
Yes. So with that, let's talk about things that are beyond loss expectant frequency and loss magnitude, and talk about attack. A great framework from MITRE there. It's certainly gotten a lot of attention out there. So beyond just these risk management approaches, there's much more to IRIS than just loss frequency and loss magnitude. There's the nature of loss. There is the nature of the attack, to use an overloaded term here, that's also available. So in IRIS 2020, we mainly focus on those first two sections, the loss expected frequency and loss magnitude, and that's certainly been well received, and we're happy to continue to do that work though. As we went on to extreme, we looked at 100 of the largest loss events and included much more detail about the threat actors and the actions that they took that resulted in those very large events. It's impossible for us to do that kind of manual analysis on 100,000 plus events that is represented in our entire data set. So we spent the past couple of years working on a number of different techniques to say, how do we classify patterns, attack techniques, and yes, even various actions and attributes at scale over the entire data set, to say, how can we provide this kind of guidance to the entire data set that we have, even if we don't have that information directly provided to us. And what we're thrilled to provide are these, on one level, we have what we call incident patterns, which are 8 or so patterns you can think of in terms of various style things, if you're familiar with the DBIR, the Data Breach Investigation Report from Verizon, of taking about what's most common. So what we have along the x-axis here is the frequency. How often do these things occur? On the y-axis, we have the financial impact. How much did it cost? That dotted line represents an even split between how often it occurs and how much it costs. So if something is typical or median or occurs about as much as it tends to cost, it would be right on that line. If it's above that line, it has more financial impact given how often it occurs. And if it's below that line, it means it has less financial impact given how frequently it occurs. And we see some really interesting changes here. System intrusion, so this is your typical hacking and malware style events there, are a large proportion of the data set and actually cost much more than would be expected based on how often they occur. Accidental disclosure, so these are the oopsie kind of moments of bad publication, leading systems exposed, et cetera, there, occur less frequent, and actually have a much less financial impact. Also, you may notice down here is this tiny little dot, relatively speaking, ransomware. Ransomware certainly gets lots of coverage out there, but it is certainly important, but it is not the most important thing in terms of how often it occurs, how costly it is. And Olga, I know DHS has been working on ransomware quite a bit. Could you care to mention that?
Yeah, so I want to caveat your previous comment by saying it's not the absolute frequency that we're worried about. It's who gets hit, how they get hit, and also what are protections that are there that's available. So some of the things are easier to address than others. And CISA stood up the ransomware task force to deal specifically with the ransomware because of how prolific it is. That said, if you're doing risk prioritization, these are the things that you need to look at in addition to ransomware. It's extremely important to focus on what you can tackle, not just what are the absolute threats out there that you may or may not be able to do anything about. So ransomware is certainly in that group. It's something that you can tackle with some of the really basic things, and there's more information available about that on CISA website. But if you're doing risk prioritization and scenario prioritization for planning or investment, here's a subset to focus on.
Fantastic. And yes, absolutely. We're not saying that anything that appears, less frequency here is to be ignored. But you have to make prioritization decisions every single day. Am I going to work on this, or am I going to work on that? And if you only have the ability to work on one thing, this may give you some insight, and this type of analysis may give you some insight about what is the thing that I should work on first, and then when I have time, work on the others there. Again, all relative to your organization and the particular industry that you may be in. So a little bit more about the science behind how we did this, because we don't have this information provided to us. We actually have to go out and get it. We start with ground truth. So we're actually working continually throughout the year, even when you don't get a report from us there. We're looking at hundreds of events that we have manually labeled based upon our subject matter expertise, based upon what we've been able to research via third-party methods, et cetera, out there. And then we do, we do the math. We do the natural language processing on this to decode information on these events. We evaluate literally dozens of different models there. We evaluate our performance, and then we retrain this every single month. So every month we're getting new information coming in, and we look at not just the new events, we go back and look and say, what new information do we have on old events as well that help us refine our predictions. So this is a process that continues to get better as we get more information, as we get better analysis on there, and I expect to see only more great results coming forward. If you're super interested on there, we look at two major criteria around this. This is the specificity, or the true negative rate, or the sensitivity, or the true positive rate. And essentially what you want to be seeing across each of these given categories or patterns is kind of a right angle going up there. It goes straight up and to the right. That means you have perfect discrimination. You're only finding the true instances. You're not ever giving a negative result on there. And our models on this are amazingly good, if I may be so bold. I was actually surprised to see how great these were, and I'm absolutely thrilled to see these kinds of results. This may not excite you if you're not a stats or math person, but I was like, wow, these are great curves.
Well, for some of us, it's an answer to the question is how much faith can I put in the results? So that gets me the level of comfort with the credibility.
But this kind of work is not limited to these patterns as well. This can actually be done on things like attack, as we mentioned. Attack has been a great thing that I think some of you may have heard of MITRE ATT&CK, perhaps. We can use these same type of approaches to look at the initial compromise method in an attack. Attack has many different parts to it there. The initial access is one of them there. There's also mitigations, lateral movement, et cetera, as well. We're working on all of those. What we have working right now is the initial attack methodology, the initial access methodology, initial compromise, and there's much more to come on this in terms of lateral movement and so forth. But the chart that may be of interest to some of you here is this common initial attack techniques, where we've looked at every single one of our major industries and we've ranked them. Which techniques, which tactics are being used the most that represent the losses we see in our data set. And what you see in the first and second, these are the most common categories there, is something that is not super sophisticated. There you see valid accounts there for administrative. That's actually almost half of the industries have that as their number one mechanism, where they're using valid accounts. They've guessed a password. They've compromised an account that way there. The other one that occurs quite a bit is phishing. It is, again, this is attacking the human link there. The business email compromise and phishing, et cetera, all exist as the most common techniques. Olga, I mean, when we shared this with you were saying, oh yeah, this is not surprising at all.
Yeah, this is oldies but goodies, and some of this or most of this could be addressed with the basic cyber essentials, right? So it's like we're seeing the same summary. It's a path of least resistance, right? And it's all the known things. Yes, there are events that kind of become a surprise, but nevertheless, it's oldies but goodies. Here's the means of prioritizing what you want to close off. And we have incident types, we have incident losses, we have frequencies lost by site, and you have TTPs that are used to propagate those incidents. So if you want to do prioritization that gets you at the risk management without doing deep dive on the quantification itself, there is sufficient information here to certainly start that analysis or start that meaningful planning and prioritization.
Fantastic. Now I see a little bit of chatter in the chat about, what does this mean for my company there? We talked a little bit about this in terms of the revenue slices. What about my specific firm? I'm a small healthcare institution. I want to know about the intersection of that. That is not in the IRIS 2022 report. It's already pretty long at 20 plus pages there. And if we did every single sector out there, we'd be looking at hundreds of pages out there. But there are ways of applying IRIS to a single firm. An example of that may be the IRIS Risk Retina series that we have. That is a commercial offering there, not to plug too much there, but it is a offering that we have available. There's a free version of that we've done for the nonprofit sector. So if you go ahead and download that for free, again, no registration required out there, you can pull that down and see the type of analysis you might get if you were to look at the information services sector, finance sector, healthcare sector as well. If you're interested in that style analysis, we'd love to talk with you about that there, but that is what we have from that. So with all that, thank you so much for attending. I'm going to go back and go through questions right now. Thank you especially to John Sturgis, my fellow data scientist and worker on the IRIS series there. It looks like he's been answering a number of different questions out there. Let me go through some of that.
And while you're looking at the questions, I'm going to do a shameless plug on both of our behalf. So for ransomware, yeah, that's a very valid, interesting question. There is a separate report that deals specifically with that Cyentia just produced, and it's very valuable. It's something that I'm certainly using and citing elaborately. But that discussion about what incident type is versus what's the TTP that enabled that incident or was leveraged for, to get to the action and objectives, that is a deeper discussion and addressed in both of the reports as far as the definitions, categories, and the causality is not part of the discussion because there are multiple ways of getting at ransomware and the multiple things that system intrusion can result in.
Fantastic. So just a few questions that came on the way there. Yes, our sector information comes from NAICS coding. That's the North American Industrial Classification System there. That's our primary way of looking at things. Absolutely, yes, on healthcare. I spent some time working in the healthcare sector myself there, so I have great sympathy and empathy for the healthcare sector. I think Olga said it very well in that the representation that we have in terms of loss frequency and loss magnitude is a combination of the threats and exposure in that area there. So just because we see more events happen in that area does not necessarily mean that they're under-investing or over-investing for that matter, or getting less return on their investment. Attackers will go where the value is to be had. And in healthcare, there's lots of information there. In finance sector, there's lots of information out there. So I certainly don't mean to say that any given sector is doing a bad job necessarily, only that we can compare how often those types of events occur.
And to emphasize, this is in no way pejorative on the level of investment because we don't know what their priorities are and we don't have the same aperture, same set of constraints to deal with. But that is to say that likelihood of incidents and loss of the incidents two things that would inform the investment going further. But to discern and say it's because causality is not to be had from this data, and that's a known problem, and that's exactly the challenge with risk modeling in this space.
Just looking through some of the questions, like many of these have been answered already. It's a question on methodology there. Yes, actually in the report, we go into much more detail about how we actually calculated that there. If you really want to get super nerdy into it there, you're welcome to email us at research@cyentia.com. We're happy to talk more about that in detail. We have some thoughts about creating a technical paper in the future there, but just hadn't had the time to create that quite yet there. So I think we've seen most of that there. If you're curious about extreme events there, yes, our IRIS Extreme report is a great one to look at there. That was done about a year and a half ago there. We'll probably be revisiting that in future work as well there, but that talks about that. If there's any questions that I haven't gotten to today, you're always welcome to email us at research@cyentia.com. As a follow-up to this webinar, you will get a link to the slides, and we'll have a recording available as well. But thank you so much for attending. Great having you there. Thank you again, Olga, for both sponsoring and being on this call today. And wish you all a fantastic day.